Hello, everybody. So I guess it's time to get started here. So good afternoon, good evening. I'm on the East Coast, so it's about, 6 o'clock start time. So my name is Dan Nguyen. I'm a senior manager leading Centene's Snowflake platform team. We call ourselves Skynet. And I'm joined here by Maya Malone, who's a cloud platform engineer, also part of Skynet. Today, we're excited to share our journey using cutting-edge technologies, right? Specifically, Cortex, Analysts, and Streamlit. Our session, Cortex AI, and Streamlit, are a perfect match for data analysts. It's all about how these tools transform the way we handle huge, complex healthcare data. We'll show you how this combo helps analysts work smarter, faster, and make a bigger impact. First, I want to take a quick mental step into the shoes of a data analyst. Picture a day spent digging through complex queries, trying to piece together relationships across multiple tables, and answering questions from colleagues who can't write SQL or navigate data models. It's a demanding job, and often it means spending more time data wrangling than actual analysis. But here's the exciting part. That's changing. It's changing fast. Thanks to advances in AI and natural language processing, tools like Cortex Analyst are making it possible for business users to ask questions directly in plain English, no SQL needed. This shift isn't just about technology. It's about culture. Bringing data access closer to the business is empowering more people to engage with data, and that's a game changer. With that in mind, please look at what we have on the agenda today. I'll start with a brief overview of Centene, our scale and our core mission. Then I'll dive into how we use Cortex Analyst on Centene's diverse data sets. Maya will follow up with Cortex Analyst configuration, then Streamlit and Snowflake, and then wrap it up with a live demo. Question for all of you, by show of hands, who here works with really large or complex data sets? Maybe even both normalize and denormalize. Great. To set the stage, let's look at a quick look at Centene. Understanding our context helps us explain why our data challenges are so unique. Centene was founded in 1984 in Wisconsin by Betty Brin, a hospital bookkeeper with the mission to improve access to care. Since then, we've grown significantly. Going public in 2001, launching our foundation in 2004, and becoming the largest Medicaid managed care org in the United States by 2017. Today, we focus on delivering health care programs to underserved populations. We're a Fortune 500 company, 22 in the US and 46 globally in 2024, serving 28.6 million managed care members with projected revenue of $144 billion. Yes, that's B in billion. Our mission, transforming the health of communities one person at a time. With over 60,000 employees, we deliver care that's local, high quality, and culturally relevant. Given the scale of Centene, serving millions across so many states, what do you imagine are some of our biggest challenges we face in delivering localized, quality healthcare? Medicaid is the heart of our business, essentially coverage for low-income individuals. We run local health plans across the United States, like Arizona Complete Health, Peach State Health Plan, each tailored to its community. And Better Health is our largest marketplace insurance carrier in the United States. We serve nearly 5 million members across 29 states, often offering personalized plans through government exchanges. We also offer Medicare Advantage plans in 32 states, covering over 1.1 million members. Our Medicare prescription drug plans reach all 50 states, plus dual eligibility programs in 5. Our local care models creates jobs, builds trusted partnerships, and helps members get the right care at the right time. This model tailors care in culturally relevant ways. And behind the scenes, it generates massive data sets from care coordination and compliance work. Our HEDIS and regulatory reporting rely on structured, accurate data tracked across both local and corporate plans. Making sense of all this data quickly and at scale is hard. And that's exactly where Cortex Analysts becomes critical. It empowers teams to get insights fast without SQL or technical teams involved. So how many of you have ever wished you could just ask data a question in plain English without needing to write a single line of code or rely on data analysts? Let's look at 2 key database design strategies we use every day: normalization and denormalization. First, let's skip the techie stuff for a sec. Let's talk about something real. Planning my son's 5-year-old birthday party a few weeks back. You could think about normalized data, like hitting all the specialized stores. First, the party store for the perfect Pokemon plates that he needed. Then, a special trip to the dairy-free bakery for his favorite vanilla buttercream cake. And don't forget the ice cream shop for his dairy-free cookies and cream ice cream. Each place was exactly what we needed. Super focused, no extra junk. The catch? You had to join all those separate trips to get the full party spread. Think super organized, less waste, but sometimes more trips to get what you need. Denormalized data. Think of it like Costco or Amazon. I can get all the plates, the napkins, the balloons, juice boxes, even a present, and even the cake, all in one go. One stop, boom, done. But I'd probably end up with a giant pack of paper plates that will last us a few years. Or something totally unintended because of my daughter Ada, who is named after Ada Lovelace. Think super fast data access for certain things, but potentially more storage and redundancy. So to just recap, normalized data is highly structured. Data is split into smaller, relatable tables. It keeps things clean, reduces redundancy, and ideal for complex systems like claims and compliance workflows. Denormalized data pulls data from multiple tables into one big, flat table. It's faster to query, it's great for analysts, fewer joins, less prep work. But it can become huge and make it tough for reporting tools to handle. Each format has its strengths and weaknesses, and understanding them helps choose the right structure for the right job. On the next slide, we'll show exactly how we use both at Centene. At Centene, we use both normalized and denormalized data sets. Each serves a clear strategic purpose. In our analytics space, we work with ultra-wide denormalized tables, some with over 200 columns, maybe 400 columns, with billions of rows. These are built for exploration and insights, perfect for tools like Cortex Analysts, which is currently running on this data set. Analysts love this setup. Fewer joins, quicker access, less friction. On the BI reporting side, we use normalized data. Lots of smaller, purpose-built tables. This format works best for dashboards and visualizations, where performance and clarity matter. So together, this hybrid approach gives us the speed, usability, and integrity It's exactly what is needed to work with complex healthcare data at scale. Cortex Analysts is really changing how we work with data. When it comes to denormalized tables, it's a game changer. Analysts don't need to be SQL experts anymore. They can just ask questions in plain English. It's perfect for digging into large, complex data sets and getting quick answers without writing queries. Now, Cortex is evolving. Full support for joins across normalized tables isn't quite there yet. I think it's public preview. But we're expecting it pretty soon, maybe this week. That'll open up even richer insights by connecting clean and organized data, typically in a normalized design table. What makes it even better are semantic views. Currently in public preview, they let users ask questions in natural language by translating business-friendly terms behind the scenes. This means more accurate results and opens up data access for a wider group of users. And here's the really cool part. The semantic view generator automates what used to be slow and manual process with YAML files. So what Maya will show you is kind of our process originally. We went down this path with a YAML file. That makes building and updating semantic layers way easier and faster, so we can scale without the hassle. At the end of the day, it just isn't about making faster queries. It's about changing who could ask the questions. Cortex pushes data closer to the business, and that's a huge cultural shift for us. Data democratization is happening. So now that we've shown you the why and the what, Maya's going to walk you through the how.
Thank you, Dan. So, in case anyone got here late, I'm Maya Malone. I'm an engineer on Centene's Snowflake platform team. And while I begin, all right, so as Dan talked about, Centene operates on a massive scale, and we manage vast and complex healthcare data. We have a big challenge with all this data. We have a lot of experts within their fields, but that doesn't necessarily mean they know how to traverse our data sets, how to write complex queries. They just don't always have the know-how to really get in there and get the insights they need. So we're working to transform this bottleneck. And we believe we've created an approach that can democratize data access so powerfully that everyone can be a data analyst. And they can do it in minutes instead of months. So what is Cortex Analyst? It is a fully managed LLM-powered feature that enables us to build applications capable of answering all business questions. And then you might be wondering, what is actually making this so transformative for the user base? So as Dan talked about, one of the most amazing features is that anyone can ask questions in plain English and get back the exact insights they need without writing any code. So I want to paint a little picture for you based off of this. If you could imagine yesterday, we have a user, and they want to understand a new data pattern they're seeing. For them, they have two options. They can wait weeks or months while they work to generate complex SQL, look through all the denormalized tables, really parse through our data set and try to find the answers. Or they can look through old reports that may or may not provide the insights they really need. But today, the same person can simply log into Snowflake, access Cortex Analyst, and start getting their answers back immediately. They're not training for SQL. They're not waiting in an analyst queue. There's no technical barriers. So from here, our goal has been very simple, but very important at the same time. We're trying to democratize data access by letting the users ask questions the way they think. We don't want people to have to think like a computer to get the really important reports. Really, if we have our way, they'll forget they're working in a database at all. So how exactly does this happen from a technical standpoint? So first, we have our users within the application space who will ask a plain English question, just like they would ask a colleague. From there, Cortex Analyst will take this question and enrich it with metadata from the data set. From this point, Cortex will begin generating a SQL query that it will run to find the answer. And finally, we'll return back a structured response containing the original question, the newly structured question, the SQL statement, and finally, the answer to our original question. But there's one more really important detail for Cortex Analyst, and it's been critical for operating within the healthcare space as Centene does. Cortex Analyst does not actually see the underlying data. It needs a roadmap to know what to look at. So for our specific use case, this roadmap has been a YAML formatted semantic model. As Dan mentioned, there's been a lot of improvements in this space, but over time, this is what we've gone with. And even better, recently, this model has been able to be generated programmatically, meaning we can onboard new data sets and new models without having to train anyone up or alter the process in any way. So, onto the semantic model. And this is where we've eliminated the technical complexity for our users. You can think of this as teaching Cortex Analysts to speak healthcare. So, the first thing we need to define is where the model will look. And we can do this by fully defining the name of one of our base table or tables. And from here, we have the time dimensions. We qualify these to minimize the need for understanding date ranges or the way time would actually work within a SQL structure. From here, we also have dimension columns. This way, a user could say last quarter, or I'm sorry, they could say by region instead of actually knowing what the data looks like. And then we also have fact columns. These allow our user to say, show me the cost per member, instead of figuring out the actual formula behind that question. However, while going through all of this, we found one aspect of the semantic model to be more important and more impressive than the rest, and that was the verified queries. So with these verified queries, we've essentially pre-trained our system with common healthcare questions and their perfect answers. So when someone asks about something like member satisfaction, the system would already know the exact methodology we're using at Centene, and it can spit out that answer without having to go through any roadblocks or any extra steps. So, as Dan talked about, a lot of our base tables are huge, and asking the right questions can take months of training or just too much time spent that could be done on more meaningful work. And so these verified questions have really helped to remove the blocker. Our users can jump right into the data by having these ready to go from the outlet. And so here's what this looks like in practice. I'm going to walk through these 3 images with us and kind of talk about what we're seeing. And also, it's an important point to remember that our users do not see any of this technical configuration. They just log in and start speaking to the data. So first, as I mentioned, we have the base table configuration. So here we're defining the database schema and table name that our data lives in. And this way, Cortex knows where to look. And then, as I mentioned earlier, we have the time dimension. And this handles all of the temporal complexity automatically. So, like I said, we can ask a question such as, show me trends over the past year. And instead of learning how toDate function works, importing a date-time module, Cortex just knows this is the column for the dates, they want the past year, and it puts them together and they get that data back. No more fidgeting around with a converter or any sort of external tools to get that correct date range. And then on the third picture, we see a dimension column. This one has a bit more information than the others. You could see here we have synonyms for the name of the column. This can be important as users do not always ask exactly what we name the columns. Usually we like to name them something verbose for our data analysts, but a human is not going to ask member_region when they're trying to figure something out. So by having these synonyms, it really helps the process along. We also like to put in a description, more for the same reason, so we know what we're looking at. And also, we will define the data type and whether or not these values are unique within our table. And then finally, what I found in my experimenting to be the most important of these areas is the sample values. So these sample values can be crucial for eliminating user confusion as well as training the model. When a user asks questions and they see suggestions such as Gotham City or Mos Eisley, they can immediately sort of get an idea of what they're looking at. You know, this is a city, I'm extrapolating here, and they can really get into the data from that example. And at the same time, on the Cortex analyst end, the model is learning our data patterns. It is taking these so that when someone asks a question about a city that we've already defined as a sample value, it knows to go look at this column and find the correct data. No more guessing games and no trial and error. So, on the back end of Cortex Analyst, our application is communicating through its REST API integration. And, you'll hear me say this a few times, the beauty of this is that the users are not seeing it at all. We take their question and we send it over to the REST API gateway. And we get back a structured response. And this response can contain multiple content blocks, text answers, suggested follow-up questions, and even generated SQL statements. This response structure can give us a lot of flexibility to create a guided experience for our users. They can get answers to their question, where they can extrapolate from there and ask more, or they can get more suggested questions that they can go along the path of to continue their journey. And so, as I mentioned, it also is printing out the SQL statement that Cortex is running on the back end to actually find this data. And I found that it's very important to have this display because while we do want our users to be able to interact with this tool from the get-go, it's important that someone is able to monitor what's actually happening. So by getting these SQL printouts, we can go in and verify that it's actually checking the right columns, printing out the right data, and really know everything's in the right place. Because once again, Cortex is not actually seeing our data. It's just seeing what we've defined. So, as we've talked about, Cortex Analyst is revolutionizing how we can interact with data. But to really create a seamless self-service experience, we need an application framework that can live natively within Snowflake. And that's where Streamlit comes in. Or specifically, Streamlit in Snowflake. So, what is Streamlit? Streamlit is an open source Python library that's become a go-to tool for building data applications. But Streamlit in Snowflake is where the real power lies. We can build applications that analyze data entirely within Snowflake, so we no longer have to move the data in or out. We don't have to worry about external dependencies. It's all right there at our fingertips. And so to really drive this point home, Streamlit apps are first-class Snowflake objects. They have full role-based access control, and we're able to maintain all of our security and compliance requirements within them, while still delivering the best consumer-grade experience possible. Performance-wise, these applications run directly on Snowflake warehouses and use internal stages for storage. So it's very similar to what you've already come to expect from the environment. And finally, Streamlit and Snowflake can work natively with all of the other Snowflake objects that we've come to love, such as Snowpark, UDFs, stored procedures, and other native app frameworks. This way, our users can jump right in with already knowing the data set. There's no new training. There's no extra work on that end. You're just right into the data, ready to go, as has been our goal with Cortex. As I mentioned, it's working seamlessly within our entire Snowflake stack. So from here, I want to talk a little bit more about why specifically Streamlit. I'm hoping at this point you get the idea, but I think doing a deep dive could be good. So, as we've alluded, the role-based access control is happening automatically. For example, a regional care manager could log into Streamlit and immediately only see their region's data. And it wouldn't be because they spent a while configuring filters or finding workarounds. The system just natively is able to set this up for them, just as we've come to expect from Snowflake. So this even allows our dynamic data masking and row access policies, which are vital within the healthcare industry. This way, we can still respect the PHI and other important information of our patients while also being able to provide this at scale. And an added bonus for developers, Streamlit is incredibly portable. The demo you're about to see has been enabled with only 200 lines of code. And in my opinion, it does not look like it. So we also have a real game changer for the self-service aspect here, and that is the execute as owner functionality. Many of you might be familiar with this, as stored procedures offer a similar usage. And so Streamlit and Snowflake, well, let me step back for a moment. A big issue with self-service analytics is that you either have to give users dangerous levels of access or restrict the tool so much it's no longer useful. However, by allowing these data tools to execute as owner, we're allowing users to perform administrative tasks without actually having any of the roles required to do so. And the flexibility of Streamlit lets us really contain this and keep it safe from a platform perspective. So we want our users to be able to get the insights they need and do the work that's important, but at the same time, maintain our security structure. And I think we've done a great job in doing so with Streamlit. And even further, I want to talk about how we've been using this on our team over the past year. So we've been utilizing Streamlit and Snowflake to transform our platform management. We've streamlined service user management and warehouse maintenance through intuitive self-service applications. Many of you are probably familiar with this kind of access. You need new service users, you need to change your warehouses as your work changes, and usually it's a long process. You need to get approval, maybe you're going through Access Central. You know, there could be many paths to get this. But with execute as owner from a Streamlit application, we can provide it all within the app space already. You need to make that change, it's there and ready to go. So now our team has a lot more free time, and there's no more provisioning these small objects, and we can get back to handling what's really interesting, like enabling Cortex Analysts. So on this slide, I have a screenshot of some Streamlit code, just to kind of show you the readability and the simplicity of it. It really is just some Python functions and some API calls. And while we're here, I want to pause for just a moment and make a point of mentioning that this data and all the other data you've seen within our slides and will shortly see within our demo is completely synthetic. As a healthcare company, we are not displaying any of our patients' data on a big stage or a big screen. This demo, this screenshot is from the Tasty Bites that you will find in the Snowflake documentation. And when I move on to our demo, you will find that while it performs as real data, it is not at all. I've created it using synthetic Python packages. So when we see members reporting up to Dr. Anakin Skywalker for their primary care, just know that that is not a real doctor. All right, now back to Cortex. So we've shown you how Cortex Analyst makes data accessible through natural language and how Streamlit provides the perfect platform for secure self-service applications. Now I want to show you this power in action. So let's move on to our demo. Awesome. So before I actually get into querying Cortex Analyst, I want to kind of show you what our semantic model looks like. I'm going to zoom in so hopefully everybody can see what's going on. So as you can see, it's very similar to the screenshots I've already displayed. We've started by putting in our base table, showing it exactly where to look, as well as a time dimension. As I mentioned, for our actual application, this is a much larger semantic file. It has a lot more data in it. but I've simplified the data set quite a bit for the purposes of a demo. When we run this usage within our company, we're running on a table with over 200 columns, a few billion rows. For demo purposes, we're sitting around 20, 30 columns, and I think 10 million rows. It's still sizable, but it's not quite what you would see in the actual production data. So while I scroll through this, you'll see the base table, we have our time dimensions, as well as just what you would expect from normal healthcare data sets. We have the age of our members, the states they're from, more address information, their phone numbers, email. As you could see looking through this, it was very important to not use real data. We don't want to dox the entire data set. So from here, now that you've gotten a bit of an idea of what we're working with, I want to scroll down and show you our verified queries. And you'll see more of these in a moment when I get to the actual Cortex Analyst. But these are our go-to for beginning the application. So from here, and I do want to give a little disclaimer, I am on mirror mode, so you'll see my prompts beforehand. But, all right, we have to give it a second to load, but we should be there momentarily. All right, so I want us to go through this as I did when I first started. I found Cortex Analyst really exciting because I am just an engineer. I'm not a data analyst. We manage the platform. We do not manage the data sets within it. So when I set this all up, I learned about our data by using the tool. And something I always like to start with is just asking for an overview of the data. Just give me something to go off of for my next questions. So that's what I'm going to start with here as well. Please give me an overview of the data. And it will take a few seconds, but it's usually pretty quick. And so here you can see we have a printout that talks about the demographics, healthcare plan detail, eligibility status. It's sort of a vague summary of the different columns it can see from that semantic model. And then here we have our synthetic, or I'm sorry, not our synthetic, we have our verified queries. And so if I go back, you'll see that we have marked these as onboarding questions. So when you start, they're ready to go, and you can really kind of dive in from that point, as I've talked about. So from here, I will start on one of these because I do find it very interesting. So just as a go-to, what are the top 10 doctors in the 10 most populous states? Perhaps we're looking at any number of reports that we want to generate, and we can see here. So on the first question, I'll go through these a bit more as we go, but you can see a big SQL printout. I think being able to see the SQL really paints a picture for how efficient Cortex Analyst is. No matter who you are not typing all of this in the 20 seconds it took Cortex Analyst to generate it. Even if you're very intimate with the data set, I don't know anybody who can type that fast. So from here, we'll see that I found, okay, California Prime Care Plan seems pretty popular. We have a lot of patients in there. And so of these patients, perhaps I want to find out how many are eligible as of our most recent audit. And once again, I'm just asking the question, and I'm giving it a moment. And we can see that as of the most recent, we have 22,000 members. And we can see our query once again. And so what I found really interesting, exciting, pick your word of choice, was how I could really deep dive by asking these questions. So I saw that this Prime Care Plan seems to be pretty popular. And now I'm asking how many eligible members are there. So maybe from here, I want to find out in this plan, what is the breakdown of our different care types, specifically complex care? Perhaps I want to generate a report for our spending within a certain state or within a certain plan, and I want to know what are the outliers? Who has these extra steps within their daily care plan? So from here, I'm seeing that the majority of people don't have any, but there's quite a few people who are under this LTSS complex care, which I know stands for long-term support. I don't always remember what both the S's are, but let's go with long-term support. And so I may be wondering, is there something to do with the age that would need this complex care? Is this age-based? What exactly is this sourcing from? Where's this data coming from? So maybe I want to find out, over the last year, of our members within the California Prime Care Plan who are eligible, what is the average age? So every audit over the past year, and I'm hoping to see some sort of pattern here. And I do want to say, while we're going through this, because it is sample data, we might not see those patterns, but on the actual data set, it does return what we would like. So I'm seeing here, maybe there's an age correlation. These all seem pretty similar. You know, they're not old per se, but they're not young. I could extrapolate from here. And then, but I'm curious, so this looks okay, but are there outliers? What's really going on? I want to go even farther. So I simply just ask, are there outliers? And I found that asking questions in this way can often, so I believe it is because of my sample data, but I found when I ask this, sometimes I get nothing, and then other times it will see that it's not returning, and it will ask me, what do you really want? So when I was practicing this demo, at times I would ask this question, I would get a printout of, what do you mean by an outlier? Are you talking about people in the top and bottom 5%? Do you want me to look up the interquartile range? And I found that really, really valuable, especially as someone who is not a data analyst by trade. I would probably have to spend a bit on Google to figure out exactly which one of those I want, but Cortex here is just figuring it out for me. So, as I said, one of those questions that I found was, it will say, do you just want the top and bottom 5% as your outliers? Is that what, you know? And I would say yes, that's an outlier in one way or another. So I'm going even deeper once again. And I do, as we get more and more, I found that the query speed stays pretty consistent, which I also found impressive. Something like, show me a count of top doctors per state. That's not a super complex SQL query. It makes sense, it's so quick, but something like the percentage of a specific column over a specific time in a specific location, you know, we're getting a lot more complex at this point, but we're not actually seeing much change in that time. So we can see here, Dwayne and Russell are really occupying a lot of this outlier space. But still, it's very interesting to see. And as I said, I could go back and refine this more. You know, I'm seeing repeats, consolidate it, just show me, you know, the distinct names of these members. Really, it's at my disposal as I would like to go deeper. And I could keep going. We could just keep getting deeper and deeper. I could zoom back out and look at a different state, and maybe I will do that. Also, we have a team member who went to Alaska recently, so I was curious, what does this data look like in Alaska? Zooming all the way back out, I don't have to change context within Cortex. I'm not, you know, changing my table, changing my role to find this new data set.
Add a second.
I have a new question, completely different topic, and it's just right in. As I talked about quite a bit in my presentation, I'm not training, I'm not changing context, I'm just, you know what, I'm done with California. Tell me about Alaska. What's going on here? I want my reports on this part of the country now. And yeah, so I found this all really interesting. I think it's very transformative for the healthcare space. We could see Dr. Frodo Baggins is very popular if you're in Alaska. Yeah, and this is really, I want to stop my demo here before I just keep going forever. But I think it's really valuable to be able to get these insights from our data without, as you've seen, I haven't typed any SQL. I haven't looked at a table. I haven't grabbed columns. I've really done no technical work here. I've just talked to our data set and then gotten exactly what I needed. As you can see here, my last little question, I wanted Cortex to thank you, but Cortex is focused on the mission and will not do anything else. So thank you, everyone.